So welcome to our combined class. We're going to look at probability. We're going to look at application of probability. We're going to look at regression analysis as well. So probability, I must confess to say, it's complex. You can never be a professor or a pro in probability because there are chances that you will get mixed up. So I'll try to be as basic as I can. So I'll start by firstly explaining what the formulas, which we call axioms of probability, entail. To start with, probability is a likelihood that an event will occur. What is a chance? I get those questions a lot to say, where do we even apply probability from our daily lives? Every day, there's a probability that an event will occur. The chances that if you're exposed to air, cold air, you get some pneumonia or cold, the chances that you're going to have a baby boy or girl, it's all an issue of probability. Probability ranges from 0 to 1. So we have words that you need to understand in probability. Words like and. This is the same as multiplying or the intersection sign. Words like or. This is the same as addition or uniting. So we're going to look at what is called set theory, which discusses how sets behave. So A and B can be added. When we add them, we remove the intersections there. So A union B is when we add sets for A and B. So this is called the intersection. So when you add set A and B and you remove the intersection, we call that A union B. The multiplication of probabilities of A and B will give you an intersection. Intersection has 5 formulas. So if you're given anything besides, if you're only given A and B, when you multiply them, you get an intersection.
Hi, Collins.
Yes, please.
Sorry, I've just joined. I joined a bit late. I don't know whether you looked at the questions you gave us last time. I don't know. There's some questions you gave us to attempt last time. I don't know whether you've answered them or...
No, we've just started.
Okay, thank you.
All right, so we have the axioms of probability between A and B. So if you're multiplying probabilities of A and probabilities of B, what we get is the intersection. If you multiply probability of A given B times the probability of B, remember these are whenever they're the same, we get an intersection. B given A times A, we get the intersection of A intersection B. So this all comes from what is called Bayes' theorem. If we have A given B, our B is the denominator, it will go down. Then on top, we're going to have A intersection B. A intersection B. So this is how we expand this function. Similarly, if we have B given A, we're going to have our A go down in this expansion. Then on top, we're going to have the probability of A intersection B. So this is how our expansion goes. So you discover that this B goes down there. This A will go down there. And again, when we multiply this B given A times A, we get the intersection. So this is where this notation is coming from. A given B times B will be A intersection B. B given A times A will be A intersection B. So this is how it goes. So if you want to look at the principles of what? Independence. A given B must be equal to A, or B given A must be equal to B. This is an independent rule. We can only say A and B are independent if what is down doesn't affect what is on top. A given R must still be A. A given Z must still be A. B given A must still be B. All right? Then if you have nothing in common, it means you are mutually exclusive. It means the intersection of A and B is 0. So these are key principles that you can never guess. If you don't know, you don't know. So an examiner will give you examples of sets. For instance, you have probability of A as 0.2, probability of B as 0.5, and probability of B given A as 0.4. So from the formulas I've given you, how do we find the probability of A intersection B? We can simply multiply A and probability of B directly if we don't have this guy. But this is Bayes' theorem. It negates that rule. So don't make a mistake of just multiplying this. It means we're going to multiply the probability of what? B given A times which probability? B given A times what? The probability of A. Whenever this is the same as that, it will make an intersection. So B given A is 0.4. Probability of A is 0.2. When I multiply that, I'll get 0.08. Should you forget the shortcut formula, always start from what you're given using Bayes' theorem. B given A using Bayes' theorem, I said, firstly, before you look at anything, drop this guy down here so that you don't make a mistake. Then you intersect them, starting with the letter which comes first in the alphabet, A intersection B. Then you substitute. B given A is 0.4. The intersection we don't have. Then probability of A is given by 0.2. So in that regard, you cross multiply. Is my network clear? Are you able to hear me? Am I audible enough?
For me, it's breaking. For me, it's breaking.
For the others, am I clear enough?
No,
Yes,
you're breaking. You're actually breaking.
Okay, thanks for that. Let me. So when you cross multiply, you find 0.2 times 0.4 to get 0.08. So I've used two methods, but I'm getting the same answer. Before I proceed, help me. Suppose you're given probability of A as half, probability of B as a quarter, and a quarter, and probability of A given B as 3/4. Can somebody help us find what's the probability of A intersection B? How do you find A intersection B? It is probability of A given B times what?
times B.
Times B. Good.
Times B.
So what is A given B? 3/4. And what is our probability of B? A quarter. So we're going to have 3/16. Or if you're not comfortable with fractions, you can put them in decimal. You have 0.75 times 0.25. What are you getting? The other alternative is you get the conditional probability that you have, you expand it. Down, we're going to put the probability of B. On top, we're going to put A intersection B. So A given B, we're going to have 3/4. And A intersection B, we don't know. And probability of B, we're going to have 1/4. So to get the intersection, we have 3/4 times 1/3, 1/4, which will give us the same answer. All right, we're going to get, what did you get? What did you get? 0.75 times 0.25.
This is 0.18.
1875. Okay, I want to move bit by bit. I don't know where we usually get it wrong. Okay, so suppose we have probability of A. The first question we had 0.2, probability of B 0.5 and B given A 0.4. Solar, how do we find the complement of A?
You subtract complement of A. Is it to subtract from 1?
The actual
Yeah,
probability of A,
okay.
yes. You subtract
Okay.
from 1 the actual probability of A.
Yes, 0.8.
Yes, so the complement means what you don't have, what is outside. If A is 20%, what is outside A is what? 80%.
It's 80%, yes.
So what's the complement of
Okay.
B?
Complement of B is 5. 1 minus 0.5.
Which is 0.5. Good.
Mm.
And how do we find A union B? What's the formula for A union B?
It's going to be P, open brackets, A over B. No? Oh, I'm lost. I thought we're doing it like we found the other one.
No, the union, not the intersection. The union,
Okay.
probability of A plus probability of B minus intersection.
Okay.
Okay, how do you find the intersection? What is A intersection B?
A over B.
A B given A
Yes, B given A
times what?
times P PA.
Yes. And what did we find here? 0.4
0.4, yes.
times 0.2,
Mm,
which gave us 0.08.
yes.
So we go to this function here. Our A is 0.2, our B is 0.5, and the intersection is 0.08.
Mm.
So what do we find?
Okay, so that's 0.7 minus 0.08.
What are we getting?
0.62.
0.62. Correct.
Oh, okay.
So this means that if you get your intersection wrong, it affects your union set.
Okay. Okay, thank you.
All right. Next, how do we find the probability of the reciprocal? B given A. How do you find B, A given B? Who can expand A given B?
Let me try.
Mm-hmm.
It's going to be probability of B down, yes. And then on top it's P brackets A union B.
What intersection? Intersection.
For intersection. Okay.
Then what do we have as our intersection? found 0.08. And our B was what?
0.5.
So what do we get? Zero point 0.16. Now, if I were to ask you, are the events mutually exclusive? What is the rule for mutually exclusive? The intersection must be 0. So step 1, you state the condition. How do we know they're mutually exclusive? Probability of A intersection B must be 0. Then step 2, you equate to what? What we found. What did we find as our A intersection B? 0.08. You compare, are they the same? No. We say not what? Not mutually exclusive. I repeat. Step 1, set the condition. Step 2, compare the figure we found. Step 3, conclude. So a condition for mutually exclusive should be that sets A and B must have nothing in common. They should never meet. The intersection must be 0. So is our intersection 0? No, it is actually 0.08. They meet somewhere. So what is our conclusion? The conclusion is that they are not what? Mutually exclusive. So state condition, compare, conclude, CCC. The other question is, are they independent? Independence also has rules. Number 1, we said A given B must be equal to what? A, the top guy. Remember what I said, regardless of what is on below, the tops must be the same. A given B must be equal to A. Compare. Number 2, you should choose in the figures there. What was our A given B? We found 0.16. And our A, 0.2. So here you put 0.16, and here you put 0.2. Then you compare. Are they the same? No. So you say they're not independent. You can also use a table. Suppose you're given probability of A as 0.4 and probability of A not A, D given A is 0.10. Then you're also given probability of B as 0.6. And you have given probability of D given A as 0.04. So you'll be asked to find the probability of D, be asked to find the probability of A given D, and you'll be asked to find the probability of B given D. So we can use a probability table to do that. So the probability table is as follows. It is what will help you survive because most of them answers will be found in the table. So we have what we call the prior probability. A prior means the original probability. Probability of A, what was the probability of A? 0.4. Probability of B, 0.6. The prior must always add up to 100. Are these adding up to 1?
Yes.
Yes. Then we go to the conditional probability. Conditional follows as a slash. So this is A, D coming from, D coming from A. For it to be conditional, where it's coming from, it must be down on the letter here. So this is 0.01, 0.10. Then this is probability of D coming from where? B. This is 0.04. So conditional don't always add up to 1, whatever it may be more or less. Then we have what is called the joint probability. The joint is called the intersection. So the intersection, simply multiplying column A times column B. Column A times column B. So D given A times A will give you the probability of what? The intersection of the two letters concerned. D intersection A. D given B times probability of B will give you D intersection B. So when you apply these two, what are we getting? So here you're going to get 0.04. Here you're going to get 0.024. So whenever you're adding two intersections, you pick the common letter. So here the common letter is D. That is the probability of D. So when we add these two, we get 0.064. So this is what we call the probability of D. 0.064. Then when we go to what is called the posterior, this is the most important probability. It should also add up to 1. This is the prior and this is the posterior. So to find the posterior, we divide the total of the intersections over each total here. So this, when we divide 0.04 divided by 0.064, it will change, it will make this posterior. Instead of D given A, you're going to have A given D. So this is 0.04 over 0.064. Then this one, B given D. Can somebody tell me what are we going to have here? B given D. What are we going to have? 0. What?
0.24.
Over?
0.064.
Okay. So what totals are you having here? And what total are you having there?
The first one is 0.0625 or 0.625.
And here?
0.375.
0.375. And you total them up.
Gives us 1.
1.
To give you 1.0. Correct. Okay. So with the same information, I want us to try. Suppose we're given x as 0.3, y as 0.7. Probability of m coming from x, probability of m coming from y, 0.2, 0.4. Can you help me? Let's find the probability of m and probability of x given m, probability of y given m. Okay. Let's try. What do you start with in the table? Who wants to lead us through the prior? What do we have in the prior? What do we have in the prior? Probability of x, which is 0.3, and probability of y, which is 0.7. So are they adding up to 1?
Yes.
Yes. And the conditional probability, what's our conditional probability?
Probability of m
Mm-hmm.
over x,
Mm-hmm.
and that's 0.2.
Mm-hmm.
Probability of m over y.
0.4.
And they're not adding up to 1.
Okay. They don't always add up to 1, right? For the conditional probability.
Then there is the joint.
This is a joint. Good. Uh-huh.
Ish. Yeah.
So when we apply this one to be what? M intersection what? X. Then this will be what? M intersection what? Y. So I'm applying column A times column B. A times B. What are we getting? 0.06.
Mhm.
This is 0. What? 28. So the total will be the probability of what?
D.
What letter?
M. M.
The common letter. Which letter is common here?
M.
M.
So with the probability of M, correct. So this will be 0.34. Then we go to the posterior. Posterior. How do we do the posterior? What are we dividing?
Probability of
So,
M intersection X.
So this will be probability of what? X over M will be, what are we dividing?
0.06.
Good, 0.06 over what?
0.34.
Yes, 0.06 over 0.34. What do we get? Then the next one, it will be probability of what? Y over what?
Y over M.
0.28 over 0.34. 3, 4. Quickly calculate and give me the figures and tell me whether we're getting total.
So for the first one, it's 0.1764, 0.176,
0.176. Okay. 0.176. Then the next one.
0.823,
0.823.
0.824.
824.
0.8.
Okay. So please confirm whether when you add them up, you're getting a 1. Confirm whether you're getting a 1. When you add them.
See,
Is it
giving
1?
us 0.9. Yeah, coming to 1.
1, okay. So we can now apply this principle with the assignment we had for the part time. Let's see whether question number just use the same application. Let's apply it religiously. So we're given that what? In a board factory, machines A, B, C manufacture 25, 35, 40 of the total outputs respectively. And the total of the output is 5, 4, and 2% respectively. A bot is randomly found. What is the probability that it was found by machines A, B, or C? Questions, which ones are there? Which ones are the prior probabilities? Which ones are the prior?
The 25, 35, and 40.
Good. Are they adding up to 1?
Yes. No.
Are they adding up
Yes.
to 1?
Yes, they are.
Yes. So we have what? The prior probabilities. Probability of A was what? 25%. Probability of B and probability of C. So A, we had 25%, B 35, and C 40%. So 35 and what? 40%. So these ones are prior probabilities, must always add up to what? 1. Put 1.0 here. The next condition, conditional probability. Okay. Conditional probability. So conditional probability never add up to 1. So we have the key issue of what? Being defective. So D coming from A is what? 5%, 4, and 3. 5%,
Not 2.
4, and 3. So D coming from A is 5%, which is 0.05. Then D effective coming from B will be what? 3%, 0.03, and defective coming from C was what? 2%, is it?
Yes.
So 542. So 0.02. Then here 0.04. Now I want somebody smart to tell us what next do we get?
The joint.
Oh, the joint. The joint is as good as the intersection, right? So here we're going to have what? D intersection what? A. So then this one will be D intersection what?
B.
B. And this one will be D intersection what?
C.
See.
C. And the total will be probability of what? Probability of what? A common letter, which is what?
A
D.
or D.
You guys are guessing.
No, it's D.
D.
Are you agreeing it's D?
Yes, yes, D.
Yes, common letter D. So now let's start multiplying each of these ones. So what are we having here? Zero point zero 0.05 times 0.25.
0.125.
0.125.
125. Because it's 0.05. Oh, shoot.
Then here, next.
Before we move to that one, I found 0.0125.
Yes, it's 0.015.
0.0125.
Yes.
Next,
0.014.
0.014. Next,
0.008.
0.008.
3 zeros.
So 0.1238 like this. Like this. Confirm.
No, it's 0.008.
Like this. Then the total.
Yes.
What's the total?
0.0345.
Okay. Now let's find the posterior. Find the posteriors. What are the posterior probabilities here? What are the posterior probabilities here?
So it's a D given A. Is it D given A?
Collins, why is the first one A given B when it's D intersection A? Not supposed to be. Okay.
So it is A, the reciprocal of this one. It's A given D. So it's A intersection D over the probability of D, which is down. So you cannot get these answers without getting the total there. So what are you dividing? This one divided by that. Give me the figures quickly.
Zero point 362.
0.362.
Mm.
Then here,
To be 0.35, right?
0.406.
40, 57, 97. 40, 57, 97.
Mhm.
This one,
0.232.
23, 18, 84. Is it? All right. Then when you total this one up approximately, it will give you 1.00. So these are called what? Posterior probabilities. So if you go to your assignment, although it was done a little bit differently, it's the same concept. You do that table, you find the probability of the defectives by multiplying, getting the intersection and getting the defectives, probability of these for the defectives alone. Then you divide each of these ones here over the defectives. So probability of A given D, it is 0.0125 over 0.03. We found 0.362. B given defective, you get this. C given defective, you get this. So the answers we are finding here are simply the same answers that we have found using this logic framework. All right. So as we go through your assignments, those who didn't do well, please, for the other group, make sure you follow this. Any questions at this point before I proceed? Is it making sense?
Yes, it is. We just need to go through.
All right. So we finally go to the tables. The other tables, this one is what most students like. Contingency table. We have A, we have B there, we have X, we have Y there. We have 2, 4, 6, and 8. First thing you do is to find the totals. Let's find the column totals. What totals are you finding?
Six, 14,
10, 8, 12.
um,
So you've seen the first thing that I did was to find the totals, right? The totals in this line and the totals in there. Is everyone clear so far?
Yes.
Yes, we find the totals. The totals this side and the totals down here. All right. So to find the probability of A, you find the number of elements for A, that is 6 over the grand total, 6 over 20. What do we get? 0.3. What's the probability of B?
8 over 20
8 over 20, which is 0. What? 4.
is 0.4.
X,
14 over 20.
X is what? 14 over
14 over
20.
20.
Okay. Which is what? What are we getting?
0.7.
0.7.
0.7.
And what's the probability of Y?
4 over 20. 12 over 20. .6.
What are you getting? 12 over 20?
0.6.
Is everyone clear so far? Anyone lost? Anyone very lost? Sula, are we together?
No, we're very much together.
Schofield, are we together?
Oh, yes.
Huh?
Yes, yes.
Rebecca?
When of come back, I think I'm having.
Okay, just for you quickly, what we did is we just found the totals here. The total 2 plus 1 is 4. 8 plus 6 is 14. Then B, we have 2 plus, we get the totals there. So the probability of A is 6 over 14. Probability of B, 8 over 12, 20. We're just getting this one over the total. Y, 12 over 20. X, 14 over 20. All right. Then when we do A given B, we go where they meet A and B. They meet at 2. But the total for this number, which is down here, the B, the total for B is what? 8. So this is 1 over 4, which is 0.25. If we do B given A, where are they meeting? They're
B
still
given
meeting at
A,
2.
2.
But the total for this number here, A, which is 6. So we get 0.33. All right.
Yep.
But if we're doing the intersection of A, intersection B, they're meeting at 2, but since it's dealing with either of them, all right, the total is for both, for everything, over 20, which is 0.1. If it was A given B, the total over B, which is 2 over 8. B given A, the same 2, but over what? Over the total for A, which is 6.
For A.
But if you're doing of A, yeah, which is 6. If you're doing A intersection B, it is where they're meeting, but the total for everything, which is 20. Now, with the same theory, can somebody tell me what is X given Y?
It's going to be 14. No, it's going to be 6.
6 over what?
6 over 14.
Over 12,
Oh, okay.
which is 0.5. The total for this guy here.
Oh,
How about
Given Y, 6.
no.
Sure.
Oh, it's
Y.
Y.
8.
It's Y over 12.
Yeah.
It's 8. Sorry. Yeah, I'm looking at X.
8 over 12, okay? Which is
Yes.
0.75.
Mhm.
How about y given x?
It's meeting at the same place, but it will just be over 14.
Over 14, good. How about x intersection y?
It's
Where are they
going to
meeting?
be
It'll be 8
6.
over 20.
8 over 20. Correct.
Mm.
Which is 0.4.
I'm confused.
You're lost?
Yes, me, I am.
Okay, x
Mm,
and y are meeting at 8 to start with.
yes.
Is that okay?
Uh-huh.
So if you're
Mhm.
doing x given y, you go to the 8 where they're
Mhm.
meeting, but the total for
Okay.
the bottom guy, the y,
Which is
the total for
y,
the y,
which
which
is
is 12,
12.
convert to
Okay.
decimal,
Not 14.
not
Okay,
14.
okay.
Then y given x, they're still meeting
Mhm.
at 8, but the total for
Yes,
this bottom guy, which is what?
which is now
X. What's the
14.
total for x? 14. That's
14.
where the 14 is coming from.
Okay, okay.
But x intersection y, they're still meeting at 8,
Mhm.
but the total for
Mhm.
everything, which is 20.
Mm,
All right.
yes.
Is that clear, Vanessa?
Yes.
I need to adopt 2 children in here that I'll need to personalize in terms of QM, not in terms of age. Okay. I need you to be clear. Joseph, please pass through my office this week. I need to also personalize you. Is that clear? Joseph, you're the one from
Okay.
Dollar, right?
Yes, yes, yes.
Yeah, please come through this week. All right.
Which day?
I'll communicate to you. Wednesday is okay.
Okay.
So,
I'll communicate. I think when you come to, when I pass through the office, maybe the probability table, what we're discussing, the conditions, I think this is where I'm a bit behind. This one is not a problem.
okay. I'll need to meet you for binomial on over the week. Just get my PS line and you come to the office. Okay, for the rest now, to conclude, I will conclude by saying A union B is simply the probability of A plus the probability of B minus the intersection. So our probability of A, we found at 0.3, probability of B, 0.4, the intersection, 0.10. So when you add this plus that minus 0.10, we get 0.6. So this is how we find a union set. Sometimes they may not say A union B, they'll say A or B. All right.
Mhm.
So the word or means union. Okay. So find time to go through your assignment question. I think we had done it during the week. Question number 2, contingency table. Find the probabilities of this. So x union y, it's the same principle. Probability of x plus probability of y minus the intersection of x and y.